Good morning, students. Welcome to the class. Students, in previous sessions, we have discussed about incenter, incenter, circumcenter, and centroid of the triangle. In today's sessions, we will discuss about two different kind of centers of the triangle. These are orthocenter and excenter. In previous sessions, I just give you the detailed explanations of the properties of all three kinds of the centers along with the examples and the questions which have been asked in previous years question papers. Okay, so in today's session we are going to discuss about first orthocenter. After that we will discuss about excenter. Before starting orthocenter, I just wanted to give you a recap. At first we started discussing about the centroid. What is a centroid? The intersection point of all three medians is known as the centroid. After that, we just discussed circumcenter. What is a circumcenter? Circumcenter is nothing but intersection point of perpendicular bisectors of all three sides of a triangle. That is known as circumcenter. Third is incenter. What is incenter? Incenter is intersection point of interior angle bisectors of the triangle. That is incenter. In today's session, we are gonna to discuss about orthocenter. So we will discuss about orthocenter. Okay, this is orthocenter. We are going to discuss about this. So what is a orthocenter? Orthocenter is nothing but intersection point of all three altitudes of the triangle. That is known as orthocenter. Okay, so suppose there is a triangle and name of the triangle is ABC. This is a triangle and name of the triangle is A, B and C. If you are dropping all three altitudes, okay, so an altitude is dropped from vertex A on side BC. Let's name it AD. Another is BE, so it is dropped from vertex B on side AC. And third one is CF. So all three altitudes are intersecting to each other at this particular point. So this particular point will be known as orthocenter. This particular point will be known as orthocenter. Understand that? So intersection point of all three medians of the triangle, that is centroid. Intersection point of perpendicular bisectors of all three sides, that is circumcenter. Intersection point of interior angle bisectors of the triangle, that is incenter. And here we are discussing about intersection point of all three altitudes or all three heights of the triangle. So intersection point of all three altitudes will be known as orthocenter. Understand that? So now we will discuss the properties related to the orthocenter. Okay, so what are the properties related to the orthocenter? At first we just have to know the angle at orthocenter. Okay, at first property is that we just have to discuss about angle at orthocenter. Angle at orthocenter. Angle at orthocenter. We will discuss about this. Okay, so what is an angle at orthocenter? Okay, suppose this is a triangle. I'm saying that it's a triangle. Okay, and name the triangle like ABC. And suppose two altitudes are dropped. One is BD perpendicular to AC, another is CF perpendicular to AB, and both altitudes are intersecting at point O. So this O will be the orthocenter. So what we have to know over here, we just have to know the angle at the orthocenter. So we just have to calculate this angle. Okay, examiner may ask us about this angle BOC. So whenever we are gonna to calculate angle BOC, what will be the value of angle BOC? It will be equal to 180 minus opposite angle. 180 minus opposite angle. Okay, and we are gonna to calculate angle BOC, so 180 minus A. If in the same way you can memorize this without drawing the diagram. Here the name of the triangle is ABC and two vertices B and C are used over here. So 180 minus remaining vertex, you can say. If sometimes examiner is asking you angle AOB, where O is orthocenter, you can say 180 minus angle C. If you have to calculate angle AOC, it will be equal to 180 minus angle B. Okay, so I have provided you the direct results related to the orthocenter. Okay, these are the direct results related to the orthocenter. Suppose sometimes you need to calculate, okay, now I'm gonna to tell you the proof for the derivation of these formulas, as we discussed in previous sessions, that we are gonna to uh, uh, deep dive. Okay, we are gonna to dive deep. Okay, so that we can understood the origin of each kind of the formula. Getting me? So I'm gonna to provide you the proof of angle at orthocenter, how to calculate this. Okay, so proof is quite very simple. As we discussed, that it's a triangle ABC, and O is the center of this. O is the center, orthocenter of this triangle ABC. So O is the orthocenter here. O is the orthocenter, and we need to calculate angle BOC. When we are gonna to calculate angle BOC, it will be, you can see here, AEOD is a quadrilateral. AEOD is a quadrilateral, and you know very well that sum of all interior angles of a quadrilateral will always be equal to 360 degree. Okay, so sum of these two angles equal to 180 degree. If these two angles are 180 and this is angle A, so it will be 180 minus A. Understand that? If this is 180 minus A, it will also be 180 minus A. So this is the simple proof of the angle at orthocenter. Okay, understand that? So you just have to, if you are just preparing for SSC examination and this is a basic kind of property related to orthocenter, you just have to remember this single formula, that what will be the value of angle at orthocenter. Okay, other properties related to the orthocenter you can cover up while you are discussing or learning about similarity and the congruency. Understand that? Okay, now I'm gonna to tell you three more important points related to the orthocenter. Okay, these points are quite important for all of us. As we discussed while we were discussing studying about about circumcenter, what we discussed over there when we were discussing about circumcenter, we discussed that circumcenter is a kind of center that is not situated inside the triangle for every kind of triangle. In acute, that is gonna be inside the triangle. In obtuse, that will be outside the triangle. In right angle triangle, that will be midpoint of the hypotenuse. We discussed these three basic points in circumcenter. Same situation, same kind of conditions are gonna to apply for orthocenter. Orthocenter is also a kind of center which will not always be inside the triangle. In some cases, it is inside the triangle. In some cases, it is outside the triangle, and in some cases, it will neither be inside nor be outside. Okay, so I'm gonna to tell you all these 3 points related to orthocenter. Suppose there is an acute angle triangle. In acute angle triangle, okay, always remember, in acute angle triangle, orthocenter will be inside the triangle. Orthocenter will be inside the triangle. Orthocenter will be inside the triangle. This is the condition of acute angle triangle. If we are discussing about acute angle triangle, orthocenter will be inside the triangle. If we are gonna to discuss about right angle triangle, so in right angle triangle, in right angle triangle, if we are discussing about right angle triangle, I'm gonna to draw a right angle triangle over here. This is a right angle triangle, suppose, and I'm naming it PQR. Angle Q equal to 90 degree. If someone is gonna to ask you the orthocenter of a right angle triangle, always remember that 90 degree vertex of a right angle triangle will be its orthocenter. So in this triangle PQR, angle Q, vertex Q is the 90 degree. So this vertex Q will be orthocenter of this right angle triangle. So in right angle triangle, 90 degree vertex, 90 degree vertex, 90 degree vertex will be 90 degree vertex will be orthocenter. 90 degree vertex will be orthocenter. This is the property which is going to apply on right angle triangle. Now we have to know that in obtuse angle triangle, in obtuse angle triangle. Orthocenter will be outside the triangle. Orthocenter will be outside the triangle. Orthocenter will be outside the triangle. So these three things you have to keep in your mind. Okay, so that's enough for the orthocenter. Understand that? So always remember what is orthocenter, how can we calculate angle at the orthocenter, and where it will be situated in different kind of triangles. Okay, so you have to remember these things, and just you can simplify easily the basic kind of questions which are based on orthocenter. Okay, now along with orthocenter we are gonna to discuss about excenter. That is also important, and many questions have been asked from excenter also. So we will discuss about excenter, and all the properties related to excenter are gonna to apply on circles also. So we will discuss about excenter. So what is excenter? This is the fifth and the last center we are gonna discuss about. Okay, excenter. Suppose there is a triangle. I'm drawing a triangle over here, and name of the triangle is ABC. Okay, so you know very well it has three sides, three vertices, three interior angles. In the same way, there will be three exterior angles. Suppose you are drawing exterior angle bisectors of two consecutive exterior angles. I'm saying just draw two consecutive exterior angles. One is B, and after B I'm drawing another exterior angle C. Okay, these are two exterior angles. So just to find out the exterior center of a triangle, you just have to draw the exterior angle bisectors of these two. So I'm drawing exterior angle bisector of these two angles. These are the exterior angle bisectors. Okay, so exterior angle bisectors of these two exterior angles are intersecting at this particular point. Okay, if BE and CE are exterior angle bisector, it means these two parts of B will be equal. I'm saying if this is x degree, this will also be x degree. Okay, if it is y degree, this is y degree, this will also be y degree. Both portions will be equal. Understand that? Now one more thing, in some questions or in some situations you will know that intersection point of any two consecutive exterior angle bisectors will be excenter. In some cases it will be mentioned that intersection point of two consecutive exterior angle bisectors and third remaining interior angle bisector will be excenter. I mean to say, exterior angle bisectors of angle B and C intersecting at point E. If you are gonna to draw interior angle bisector of angle A, that is also going to bisect, that is also going to intersect at same point E. Understand that? So I am drawing interior angle bisector of angle A, that will also intersect at same point E. Okay, so there are two definitions, different kind of definitions related to the excenter. You can say intersection point of two consecutive exterior angle bisectors. One, you can say intersection point of two consecutive exterior angle bisectors along with third interior angle bisector of the triangle, that is also excenter. Okay, now this is the property. Okay, in the same way, when we were discussing about circumcenter, what we discussed, if we are gonna to draw a circle from circumcenter, that will be known as circumcircle, and that circle will be passing through each vertex of the triangle. If we are gonna to draw a circle from incenter, that will be inside the triangle touching all the sides of the triangle, that is known as incircle. In the same way, if you are gonna to draw a circle over here, okay, if you are gonna to draw a circle from this center E, so this circle will be touching all these three sides of here. Okay, means this circle will be touching extended sides of the triangle and one original side of the triangle. Okay, and this circle will be known as X circle. This circle will be known as X circle, and its radius will be known as X radius. Its radius will be known as X radius. X radius. Its radius will be known as X radius. Okay, now Many times length of the sides of the triangle will be provided to you, and examiner will be going to ask you the length of x radius. What will be the length of x radius? So here we have drawn the exterior angle bisectors of angle B and C, and this circle, particular x circle, is touching extended AB and AC and original side BC of the triangle. Suppose length of this BC is A and it's B and it's C. In the question, length of all three sides is provided. Okay, so examiner may ask you about the length of x radius. So whenever you need to calculate x radius, okay, whenever you need to calculate x radius, it will be del upon s minus a. Okay, what is del? Del is the area of the triangle. Del is area of triangle. Area of triangle. And you know very well about s. S is semi perimeter. Okay, and a is the length of that side which is touched by the circle. So BC, this circle is touching the side BC, and length of BC is a. Okay, so we have to take, suppose you are gonna to draw the bisectors of angle A and angle B. They will be meeting somewhere here. If you are drawing a kind of circle which is gonna to touch AB and both extended sides, AB and both extended sides means CA and CB. So in that case, radius of that x circle will be del upon s minus c. Suppose you are drawing a x circle in this direction, which is gonna to touch side AC. So in that case, length of x radius will be del upon s minus b. Okay, so this is the quite simple formula for the x radius. Okay, so I'm going to tell you one more basic property which is quite important just to attend the questions which have been asked previously in SSC pre-examination, SSC CGL pre or CHSL, or many times in CDS, simple kind of questions. Okay, many times you will be asked to calculate angle at x center. Okay, angle at x center. Angle at x center. Okay, so what will be the value at of the angle at x center? Suppose you have to calculate the value of angle at x center. Firstly, you have to remind the value of angle at in center. That was 90 plus half of opposite. 90 plus half of opposite. Here we just have to calculate the value at x center. So we have to calculate this particular angle. Okay, angle BEC. We have to calculate in this diagram angle BEC. So if you are gonna to calculate value of angle BEC, so it will be 90 minus half of opposite, a by 2. Understand that? In center, in case of in center, you just have to write 90 plus half of opposite. 90 plus half of opposite in center, but x center you will have to write minus 90 minus half of opposite. It will be the value of angle at x center. If you do not want to draw the diagram, just read the questions carefully and see which vertex is remaining. Okay, so yeah, I can tell you here two vertices B and C are used. So you can say 90 minus half of remaining. If sometimes you have to calculate the angle at x center when you are drawing bisectors of A and B, then that will be 90 minus C by 2. If you are going to draw the bisectors of A and C, that will be 90 minus B by 2. Okay, so these were the properties related to orthocenter and excenter, and these are very basic kind of properties. So you just have to memorize or remember these properties in your mind. Okay, and I just wanted to tell you, keep learning and practice a lot. If you you are able to remember or have all kind of concepts and the formulas in your mind, it is gonna to be helpful for you to crack the examination. Okay, and just keep practicing the previous year question papers. Okay, and if you have any kind of doubt, you can contact me through comments. Okay, I'm gonna to reply you, and I'm gonna to give you the solutions of the questions you are putting in form of doubts. Okay, so thanks a lot. Thank you so much, and please keep sharing the things. Okay, thanks a lot.